Hi folks, we're going to take a look at page 369, number 6. So let's take a look at the question. It says a boat heads 15 degrees west of north with a water speed of 12 meters per second. So the first thing I notice is that they're giving us the direction a little differently. So let's see if we can figure out what that means. So 15 degrees west of north. So I presume what we're doing is we're starting at the north and then going 15 degrees towards the west. Okay, and then determine its resultant velocity relative to the ground. So looking for the ground velocity when it encounters a 5 meters per second current from 15 degrees north of east. So it's coming from 15 degrees north of east. So there's east, 15 degrees north of that. So it's coming from this direction. So that means it's actually going to be traveling. Looks like it's going to be west 15 degrees south. Okay, so this is actually going to be west 15 degrees south. Okay, so very important to read the question carefully to make sure we are clear on what information they're giving us. All right, so let's add these two vectors together because we know that the ground velocity is going to be given by the velocity of the craft itself plus the velocity of the current. Okay, so let me start here. So the first thing it's doing is we said it's going north 15 degrees west. So let me draw a big vector there. Okay, so here we have 15 degrees, and we know that the magnitude of this vector is 12. And then we're adding to that the current. Okay, and the current we said was west 15 degrees south, and it's going to be a smaller vector. So west 15 degrees south. Okay, so there's 15. The magnitude is equal to 5, and so my resultant vector will be this vector here. Okay, so this is the ground velocity. All right, so let's determine that. So the first thing I see is I've got my triangle. I'm going to have to find an angle since I have two side lengths. Well, here I know that that's 15 degrees. So I've got a right angle. So that means that's going to be 90 minus 15 is 75. But then, because of these parallel lines, this is also 15. And 75 plus 15, well, that's 90. So it actually turns out that this is a 90-degree triangle. Okay, it doesn't happen too often, but hey, certainly possible that we get a 90-degree triangle. So that means we can actually solve this question without having to use sine or cosine law. Okay, so since we have two sides of the triangle, we can just go ahead and use Pythagoras. Not surprising, because in the end, remember that Pythagoras is just a special case of the cosine law. All right, so here we've got the magnitude of the ground velocity is just equal to the square root of 12 squared plus 5 squared. But hopefully you recognize that as a special right angle triangle, because this is 144 plus 25 is 169. Square root of 169 is 13. So we have 13 meters per second is the speed or the magnitude of the velocity vector. And now, in order to find the direction, well, I guess it makes sense to find that angle there. And again, I can use any of my trig ratios, but I might as well work with the 5 and 12. So we know that tan of theta is equal to 5 over 12. So theta is equal to, let's get our trusty calculator here. And so we have inverse tan of 5 divided by 12, and that's 22.6. Okay, and if I want to get a direction here, well, I might as well start at north, and I've got 15 degrees here, plus this angle theta will give me the number of degrees towards the west. So 22.6 plus 15 gives us 37.6. Okay, so our final answer here, the ground velocity, is going to be equal to 13 meters per second. And then we had west, sorry, I just realized we were going in the other direction. Let's get rid of that there. Okay, let's try again. We're going north first, so north, and then we said it was 37.6 degrees towards the west. 37.6 degrees west. Okay, so let's just recap here. So in terms of the problem itself, it's just, pretty straightforward. Add the velocity of the boat plus the velocity of the current to get the ground velocity. Turned out here that it was a right angle triangle, made our lives a little easier. But the little hitch in this question here was the way they gave us the angles, a little different from what we're used to, but in particular the way they gave us the direction of the current. They told us where the current was coming from. Okay, so where it's going toward was just the opposite of the original one. So they originally gave us east 15 degrees north. That's where it was coming from. So that means it's actually traveling toward west 15 degrees south. All right, that's it for this one.